One of you asked this question as well, and this is the question that is on this. Let me just see if it's the right one. Yes, it's the one that's on the screen at the moment. It comes from the 2016 supplementary paper. Now, what's beautiful here is what I thought was nice is look at these mark allocations there. The 6 marks. When I saw it, I thought, wow, usually 1 mark, 2 mark, if we're lucky, 3 marks, 6 marks. There must be something to this question. So I've got 10 minutes to do this question with you. Let's fall away. The box and whisker diagram below shows the marks out of 80 obtained in a history test by a class of 9 learners. So that's important, folks. There's 9 learners in this class, so the sample size is 9. Comment on the skewness of the data. Now, folks, the skewness of the data is where is the tail? Now, if we look at this, the tail is to the left, so it's left skewed or negatively skewed. If we were to draw this on a diagram, the diagram will have a tail here and somewhere here it's going to do that. Okay, somewhere over there. So we can see that there's this tail on the negative side. Let me just get rid of that line there. I'm going to need that space. Okay, so the comment that I'm going to make here is it is negatively skewed. That's all you have to say. You can see that from the graph. Or it is left skewed. Whichever one you want to use there, you can use one of those two as an answer for the first question. It means the same thing. Okay, now they say write down the range of the marks that was obtained. Now, folks, that's easy. The range is the biggest value minus the smallest value. So the range is 80, the largest value, minus the smallest value, and that gives us a range of 60 points or marks. In this particular, write down the range, and look at this, they asked it for 2 marks. That was a dead giveaway. Okay, so know your work. You can do well in the statistical reasoning component of the paper. If the learners had to obtain 32 marks to pass the test. Now let's have a look. Where's 32 marks? 32 marks lie over here. It looks like it is at quartile 1. So everybody that got less than 32 did not pass the test. Okay? They said the learner had to get 32 marks to pass the test. Estimate the percentage of class that failed the test. Now, folks, you don't have to estimate if you know your work. You know below quartile 1, there's 25% of your data. From quartile 1 to quartile 2, there's another 25%. Quartile 2 to quartile 3, there's the next 25% of the data, and then the last 25% lies between quartile 3 and the top value in your data range. So if the learners estimate, it is 25% failed the test. Another 2 marks for something that you're supposed to know. Okay, so please, folks, don't throw marks away by not knowing your work. This is the nice pork chop that I'm getting to, is 1.4. It says, in ascending order, the second mark is 28, the third mark is 36, then the 6th mark is 69. So let's just 1, 2, 3, 4, 5, 6, 7, 8, 9. Remember, there was 9 students in the class. Then they tell us the average. The average for this class was 54 for the test. Okay, so let's keep that on the side and let's go back. We are seriously short of information over here. Now, if we look at what we have here, there's the 9 learners. The weakest learner had 20 marks. So we can fill in as 20. And the strongest learner had 80 marks. Your median, now check here, there's 9 data items, folks. If the number of data items is odd, you add 1 to it, you get 10. You halve that number, and that is where your median is lying. Okay, let's have a look. 9 plus 1 is 10, halved is 5. Aha! So this is where quartile 2 is, the median. And the median they gave us as 62 marks. Okay, then they also said to us in the beginning, here I am. The 7th and the 8th marks are the same. Okay, so the 7th and the 8th marks being the same mean we're somewhere here around quartile 3. Now, if we look at the data, quartile 3 lies over here. So if those two are the same, then certainly we can fill in that is 75%, and that second one, which is the same, is also 75%. The only one that is outstanding at the moment is person number 4. So let's call that P number 4 for person number 4. Okay, we don't know what that is. We do know the one quartile here, the other quartile here. You can remember the quartile was at 32. Okay, so here is where the 32 is lying. Doesn't help me, okay, because I don't need one of the two values on either side of 32. But what did they give me? They gave me the median value of the set of data. Now, how do I find the median value? Well, I take 20, I add 28, I add 30, not median, sorry guys, the mean value, the average. I add 36, I add person number 4, I add 62, I add 69 with 75, another 75 and an 80. And I divide all of that by the 9 data items that I have. And they told me that that value is indeed 54. It was given. So this here is 54. Okay, so now I've got to take my calculator and I've got to add all of these values up. Folks, you know how to add with your calculator. I don't need to show you. So if I add all of that up, I get person 4 plus 445 is equal to, so that's the top of this fraction. I'm multiplying the 9 across is 9 multiplied by 54. Now remember, I'm adding here. Okay, so what do I get? I get that person 4 is this 9 times 54 minus 445. Now again, that's calculator work, and you see you get a 41%, or 41 marks out of 80. It's not a percentage, remember? It's a mark out of 80. So you're going to get the 6 marks for populating your table. In other words, for getting this right, that right, this one right, and that one right. And then your final mark is going to go here for your 41, where you used the fact that we gave you the average for this particular test. Okay, now folks, please, when you work with statistical reasoning, first of all, make sure on the day that you write your exam, you have a very sharp pencil. If you have a clutch pencil, make sure it has lead in it. Make sure you have your ruler there. Have an eraser ready. Have your battery in your calculator checked. You don't want to be stuck with a calculator that has gone flat or doesn't work properly. Okay, so make sure that your instruments are ready for you to interpret graphs. The research over the years, folks, have shown that school children battle to interpret statistical graphs. Now, you saw the questions that I've done with you tonight. They're not that challenging. If you knew what that line at 32 represented on our box and whisker plot, you would have known that below it lies 25% of the data. Between every quartile, that's why we call them quartiles, there's 0.25 of 1. The whole set of data is 1, 0.25 there, 0.25, 0.25, divided into 4 parts. Okay, and also what you also saw happening today was with the waitering questions, when they asked you to interpret the standard deviation for the two folks, for Reggie and for Mary, I think it was, that Mary's tips, the smaller the standard deviation was, the more stable her tips were. So Reggie had a huge standard deviation, which meant there's big variation in the amount that people tip him per day in the restaurant. They might have the same amount at the end of 15 days, but the amount per day varies. Less for Mary than what it varied for Reggie, and that is because the standard deviation is bigger. Then lastly, your regression analysis, where you worked with your regression lines. Know how to use your calculator. Know that it's y equals a plus bx, not ax plus b for a regression line. If you forget these little things, you're going to get these things wrong. Okay, and then obviously, how do I find the a value? How do I find the b value? And then how do I find the r value, the regression? The bigger, the closer the data is clustered to the regression line, the stronger the correlation coefficient. Okay, folks, I hope that helped you with your statistical reasoning. Go online, get a few papers and their memos, and try this for yourself.